Hello everyone, welcome back to my channel. In today's video, I'm going to solve the questions from JEE Mains 2019. Since 2019 was given in two slots in March, in January and April, today I'm going to solve the exam from 12th April 2019, shift 1. So let's begin. Let a random variable x have a binomial distribution with mean 8 and variance 4. If the probability that x is less than or equal to 2 is equals to k over 2 to the power 16, then k is equal to. So this question is from the probability chapter, and we know that for a binomial distribution, the mean is equals to n times p, where n is the total number of cases and p is the probability of our specific outcome. And the variance of binomial distribution is n times p minus 1. In the question, we are given that mean is 8, so NP is equal to 8, and the variance is equals to 4. So NP times 1 minus P equals to 4. We can plug this value in here. So we have 8 times 1 minus P equals to 4. So 1 minus P equals to half, which says that P equals to half. Using the value of P back into the mean, we have N times P equals to 8, so N equals to 16. So we know that the total number is 16. And to find the probability that x is less than or equal to 2, we add up three probabilities where x equals to 0, the probability that x equals to 1, and the probability that x equals to 2. So for 16 cases, the probability that x equals to 0 is 16C0. The probability p to the power 16 times 1 minus p, which is also half to the power 0, plus 16C1, the probability 1 half to the power 1 times 1 half to the power 15, plus 16C2 1 half to the power 14 times 1 half to the power 2. So we know that 1 over 2 to the power 16 is a common factor, so we take that out and we are left with 16C0 plus 16C1 plus 16C2, which is 16C0 is 1, 16C1 is 16, and 16C2 is 120. So this is 137 over 2 to the power 16, which is our answer. So the value of k should be 137. Let's move on to the next question. If the normal to the ellipse 3x squared plus 4y squared equals to 12 at a point P on it is parallel to the line 2x plus y equals to 4, and the tangent to the ellipse at P passes through point Q 4, 4, then PQ is equal to. So here we are given a point Q that is 4, 4, and let's assume that the point P is x1, y1. We need to find the distance between the 2 points. So let's try to find out the point P. So we are given that the ellipse 3x squared plus 4y squared equals to 12. Let's differentiate this. So we get 6x plus 8y dy over dx equals 0. So we know that dy over dx is minus 6x over 8y. We are also given the information that the line 2x plus y is parallel to the normal. So we know that y equals to minus 2x plus 4. So the slope of this line is negative 2. And this dy by dx is the slope of the tangent. So the slope of the tangent is negative 6x over 8y. And the normal is parallel to our line. So if I were to draw a diagram of this thing, the ellipse would look something like this. Since it is a horizontal ellipse, let us just consider some random arbitrary point P. So the tangent at P would be like this, and the normal would be perpendicular to that. And we have one more line that is parallel to the normal. So the tangent and this line are also perpendicular. So the slope of the tangent, we know for perpendicular lines, m1 times m2 is negative 1. So from this information, we know that the slope of the tangent should be 1 over 2, positive 1 over 2. So we know that negative 6x over 8y equals to 1 half, which gives us that x equals to minus 2 over 3y. Using this information, we can plug this back into the equation of the ellipse. So we have 3x squared plus 4y squared equals 12. 3 times x squared would be 4 over 9y squared plus 4y squared equals 12. So this gives 12 over 9y squared plus 4y squared equals to 12. So that's 48y squared over 9 equals 12, which gives that y squared equals to 36 over 16, which means y equals to 6 over 4, which says that y equals to 3 by 2. Plugging in this value of y back into x, we get x equals to minus 1. So our initial point P, which was x1, y1, is negative 1, comma 3 over 2. So now we have point P and point Q. Finding the distance between them should be pretty straightforward using the distance formula. So we have point Q, 4, comma 4. So the distance should be 4 plus 1 squared plus 4 minus 3 by 2 squared. So that is under root 25. 25 over 4, which is under root 125 over 4. Which is equals to 5 root 5 over 2, which is our answer. Option 4. Let's move on to the next question. The coefficient of x to the power 18 in the product 1 plus x times 1 minus x to the 10 times 1 plus x squared to the 9 is. So let's factor the 1 minus x to the 10. So that is 1 minus x times 1 minus x to the 9. Everything else remains the same. Now we know this thing is 1 minus x squared because a minus b times a plus b is a squared minus b squared. And if we remember the cubic identity correctly, a cubed minus b cubed is a minus b times a squared plus b squared plus ab. And here, if we look at this remaining term, we can write that as 1 minus x times 1 plus x squared whole to the 9. And if we look closely, this is the cubic identity of 1 minus x cubed. So that becomes 1 minus x cubed to the 9. Now using the binomial theorem, we know the expansion of this thing should be 9c r times 1 negative 1 to the r times x cubed to the r, which is x to the 3r. Now multiplying this with 1 minus x squared, we get 9cr minus 1 to the r x to the 3r minus 9cr minus 1 to the r x to the 3r plus 2. Now we need to find the coefficient of x to the 18. So x to the 18 can be either from this term or from this term. So if we equate it, from here we get r equals to 6. And from this side, we get 18 equals to 3r plus 2. Here, r is not an integer. So from this side, we don't get any coefficient of x to the 18. The only coefficient is from this term when r is equals to 6. So then the coefficient would become 9c6 minus 1 to the 6, and 9C6 is basically equal to 963, which is 84. So our answer should be option 4, 84. Let's move on to the next question. The equation, the modulus of z minus I equals to the modulus of z minus 1, where I is the under root of -1, represents. So let's write z in the standard form of complex numbers, that is x plus iy, where x is the real part and y is the imaginary part. So then it becomes modulus x plus iy minus I is equal to the modulus of x plus iy minus 1. So this is x plus I times y minus 1 and x minus 1 plus I times y. And the modulus opens up as x squared plus y squared. So here it is x squared plus y minus 1 squared equals to x minus 1 squared plus y squared. If we look at the terms closely or expand this, we get x squared minus 2x plus 1 plus y squared. So we can see that the term x squared, the term y squared, the term 1 are on the both sides. So we are remained with minus 2x equals to minus 2y, which tells us that x equals y. And the line y equals to x is a straight line passing through the origin, having a slope of 1. So then looking at our options, option 4 satisfies the line through the origin with slope 1. Let's move on to the next question. If alpha and beta are the roots of the equation 375x squared minus 25x minus 2 equals to 0, then limit n tends to infinity, the sum of alpha to the r, plus limit n tends to infinity, the sum of beta to the r is equal to. So this is an example from quadratic equation as well as limits and sequences. So let's extract some information from the given quadratic equation. So we are given this equation and we know that the two roots are alpha and beta. And from our quadratic equations, we remember that the sum of the roots of a quadratic equation is minus b over a, which is 25 over 375 in our question. And the product of the roots is c over a, which is minus 2 over 375. And we need to find the limit as n approaches infinity, the sum of alpha to the r plus the sum of beta to the r. So we know that these two individual summations are basically geometric progression to alpha, alpha squared, so on to alpha to the power n. And here that would be beta, beta squared, so far to beta to the n. And we know that the sum of an infinite geometric progression is the first term over 1 minus the common ratio. And the common ratio in this case is alpha because each term gets multiplied by alpha. So you multiply alpha to the first term, you get alpha squared. Multiply to the next term, you get alpha cubed, and so on. In the same case with this sequence, we get the first term, which is beta, over 1 minus the common ratio, that is also beta. So this is the sum of these two series. So then we have alpha over 1 minus alpha plus beta over 1 minus beta. We need to solve this equation. So which gives alpha times 1 minus beta plus beta times 1 minus alpha over 1 minus alpha times 1 minus beta. If we expand these, we get alpha minus alpha beta plus beta minus alpha beta over 1 minus beta minus alpha plus alpha beta. And now we know the value. So here we have alpha plus beta. So we know the value of alpha plus beta, that is 25 over 375. And then we have minus 2 times alpha beta. So that is minus 2 over 375, and it's 2 times. And then over we have 1 minus. So this thing can be written as minus of alpha plus beta. So that is 1 minus 25 over 375 plus minus 2 over 375. And if we solve this, it comes to 1 over 12. So the correct answer is option 3, 1 over 12. Let's move on to the next question. For x in 0, comma 3 by 2, let f of x equals to under root x, g of x equals to tan of x, and h of x equals to 1 minus x squared over 1 plus x squared. If phi of x is equal to h of f of g of x, then we need to find phi of pi over 3. So this is an example from the functions chapter. So we are given f of x equals to under root x, g of x is given as tan x, and h of x is given as 1 minus x squared over 1 plus x squared. So let's find phi of x, which is h of f of g of x. So that means h of f of g of x is tan x, and f of tan x should be, so instead of x we plug in under tan x, so that is under root tan x, and h of under root tan x should be 1 minus under root tan x squared, so that is tan x over 1 plus tan x. So we basically have our function phi of x over here, and we need to find phi of pi over 3. So just plug in the value of pi over 3. So we have 1 minus tan of pi over 3 over 1 plus tan of pi over 3. This thing, if we remember the trigonometric identities correctly, this thing is tan of pi over 4 minus pi over 3, which is equals to tan of 11 pi over 12. How we got this trigonometric identity? So we know that tan of pi by 4 is 1. So in the numerator we have tan of pi by 4 minus tan of pi by 3, and the denominator is tan of pi over 4 plus tan of pi by 3. And that is basically the formula of tan A minus B. So this is where we get the trigonometric identity from. So our answer is tan of 11 pi by 12, which is option 2.